That's definitely videoing. Right. Okay, so we're going to move a very, very small step forward today. Last week we were working on objects, classes, and inheritance. All right, and we did the example with the biped and the quadruped. We do that one. Okay, so I'm not going to go very much further, but there's two sort of little kind of gotchas to do with inheritance in C#. Okay, so I'm going to spend a bit of time today talking about number one, this concept called constructor chaining. All right, so this is if you create a dog class, what happens with the constructor of the base class? And that's the first thing. The second thing we're going to talk about is static and dynamic function or method binding in C#. And it's a little thing that C# does and C++ does that Java doesn't do. So it's just a little subtle thing that can confuse people if they don't know about it. And on Friday, we're going to make a game. So no more console apps. Okay, we're going to make an actual game. And the game we're going to make, it's like a bit of a hello world of games. I'm staying home Wednesday to work on it. And I'm going to try and probably get it running on the iPad and everything on Wednesday. It's going to be based around my dog Misty. So I'm going to call it Misty Bats, right? That's your clue, but make sure you're here. When is our next class? Tomorrow. Alright, we'll do it tomorrow. An awful lot of time. I'll try and get it knocked up today then, right? Okay, so the last day we were working on this little dog and cat. So I'm going to simplify this example that we're doing today because I just want to give you an example of two new concepts. So I'm just going to create one base class and two derived classes, right? Or two subclasses. And the base class I'm going to make is, did we do mammal or animal? Animal, right? So I'm going to make an animal base class. Public class animal. So I'm going to give this a couple of properties. What properties did we make on our animal class? A name and an age, is it?
Name, age, walk, talk.
Right. Okay, we keep it really simple today. We'll just make a couple of ones. Let's make private string name. So all animals have a name. And private string age. What other one did we make? Number of legs. Yeah, that's just, it's going to become tricky to sort of work that into it. So we've got a name and an age. Now, so I make these private, and these are what we call fields in the animal class. So I'm going to right click on them, choose refactor, encapsulate field in order to make the getters and setters for me automatically. So then you click on apply.
Will not be private int age.
Yeah, you're right, it should be private int age. Thank you. So, one thing, you know this refactoring that I'm doing, that isn't available in the Visual Studio Express editions, it's only available in the professional one. So I'm right clicking on that again, and I'm going to click refactor, encapsulate field. So now I get an age property, which is private, an age field, which is private, and an age property, which is public. And you can see that they're not doing anything terribly complicated, they're just taking the field and returning it, or taking the field and setting it. So, in the example we'll say of the name here, when you go name equals value, where does it get value from? In your setter, where does it get value from? Can anybody tell me where does it get value from? Well, we did getters and setters. This is like a method. It's like a method called set, and it takes a parameter, which is the thing you want to assign to the name field. Where does it get value from? Anybody? Who is reading the chapters from, just put up your hands, who's reading the two sections in Rob Miles' yellow book that I recommended? Who read those? Section 4.9 and section 4.1. Who didn't read them? Just put up your hands. Okay. There's a few people there I would expect not to need to read them, but there's a good number of you there that I don't know why you didn't read it, but that's your choice, alright? I'm going to assume you've read it, you know. You know, that's why we did the contract thing. The value comes from the OR value. When you go and create an instance of the animal, you go animal A, when you go A.name equals, and then you give it some name, that's where it gets it from. It gets it from what's called the OR value in an assignment statement. So we got the name and we got the age, and let's make a constructor for this. Right? Let's make a couple of constructors here. Let's make a public animal And now, this is our default constructor. So what I want to do in the default constructor is set the name and set the age to be 0. Okay, so I'm just going to give them some default values. If you construct one of these objects without passing them in, I'm going to just create some default values. Now, this is the first thing I wanted to show you. This is the idea of, making use of your constructors more efficiently. The one thing we don't like to do in programming is copy and paste. Isn't that right? Copying and pasting is bad. It's much better to try and reuse your code. And this is an example of where you can reuse the constructor. So we can have multiple constructors that take different parameters. So we can have a parameter which takes the name and takes the age and takes those two values and assigns them to be the properties, or the fields. So you can go name equals, and then we have this issue here that I want to use this. I want to take this name and assign the value into here. So how do I disambiguate? To use this. So this.name equals the parameter name. Oops. And this.age equals the parameter age. And if you don't understand what I'm doing here, you need to read the book. Because it just means that you maybe have a different learning style, and maybe you understand things better if you read them or you see them in a book, right? So, so what I want to do now is I want to reuse this. So I have my default one here, and my default one I want to set the name to be the empty string, and I want to set the age to be the value 0. So one way to do it is to just do this: copy and paste, and go that's equals to that, and that's equals to 0. But we previously said we don't like copying and pasting. Alright? So what I really want to do is, if you try and construct an animal using this constructor, I want to call this constructor, but I want to pass in the empty string here and 0 for here. So how you do that in C# is by using the this keyword in a very particular way. So you do that by doing this. You go colon this. And this is a bit bad, right? Because in C++, the syntax is different, and you use the constructor name, so it's a bit more explicit. But in C#, we're using the word this to mean two different things, but that's just the way the language is designed. This actually means a reference to the current object, but in this context here, it means call the constructor. Call the constructor. And you notice that it says, hey, there's one of two constructors. The one I want to call is the one that takes name and the age. So you can go this, like that. Alright? So what actually happens here is, if I construct one of my animal instances by using the default constructor, before it does this bit here, it will actually do this bit here, and it will pass in empty string and 0 for name and age, and it will do this bit of code here. Is that okay? I'm going to run this program, and when you run the program, there's absolutely no ambiguity. You just see, it just does that, and that's exactly what happens. So what we can do here is, just to be very explicit about this, I'm going to make an extra constructor, one where you just pass in the age, one where you just pass in the name, and it sets the age to be 0. So you can go string name, so name and 0. Alright, so this is another example of a constructor. And this constructor here, we just pass in the name, so it passes the name into this constructor, it will construct it this way, and it passes 0 for the second parameter in here, so the age gets assigned to be 0. Is that alright? Let me do an example of this, right? Before I go making a subclass, let me do an example of that to just illustrate that concept. You can create an instance now. There's 3 ways to create animals. You can go animal A equals new animal, like that. And when you do your open bracket here, Visual Studio tells you there's 3 different constructors. And you do down arrow there, and it says there's one that takes just the name, one that takes the name and the age, and one that doesn't take anything. And you can construct it using either one of those 3 constructors. So watch what happens if you do this constructor here. Animal A equals new animal. So before we even run this, what's the name and the age of that animal going to be? The age is 0 and the name is going to be? The empty string. The name is going to be the empty string because it's going to call the one here. It will call this one and it will pass in the empty string and 0 for those 2 parameters. Let's do another one. Animal B equals new animal. And this time we'll pass in Brian. and we'll pass in nothing else, just the name like that. Okay, so in this one here, what's the name going to be? And what's the age going to be? 0. So we'll use, and in fact we'll set the breakpoint, we'll do a breakpoint here and we'll step through it so you can see the sequence of those constructors getting called. And we'll do the third one then. Equals new animal, what will we call it? Daisy, the cow. So I guess you can see straight away that it's going to use a name of Daisy and an age of 10. Okay, so you can see from here, but I want you to understand what exactly happens with those constructors and what this keyword means there. So I'm going to press F5 to run this program now, and we can step inside this constructor. So watch this, animal A equals new animal. So I'm going to press F11. What does F11 mean? Step into. And watch where it steps into. Where are you? So here we go. This is it's here now. So animal, and then I go this, the empty string. So I'm going to press F11 to step into again. And you notice it will have jumped up to here. So it's actually passing, and you can hover over name, and you see name is the empty string, and age is 0. So you see when you use this in this context here, like you use the constructor like this, what this means is call that other constructor before you do the bit in this constructor. So then you do F10.
Say if you made a public animal that took in, say, string, last name, and int, an owner's age.
Sure.
And but after that, you still use the public animal this, and then put in them parameters. Those parameters would be assigned to that one as well, even though they're not the values you want.
Not sure I get you.
See the way you have
We say yeah. We'll do the code, right? Animal D equals new animal. Yeah.
Well, it's the values on the front and the owners on the past page or the last one.
Oh, sorry, my apologies. Right, let's jump back to the other one. Yep.
See the way you have the public animal, string name, then int age, and then
yeah.
Say if you did a different one below that with public animal, string, last name, int, owner's age, sort of thing.
Sure. You just call the parameters different parameter names, is it? Okay, let's do it. Public animal. So string, owner's name, right? Owner's name and
owner's age.
Yep. Yep.
Say if you to go down again for.
Okay, so we do have a little bit of an issue here.
Yes.
Number one issue here is the actual names of the parameters don't matter, but the thing here, well, one of the things we have is now I have two constructors that take a string and an int, so it won't know which one to call. So it's not just that the parameter names are different, you must have different types. You know what I mean? Otherwise it won't know, if you pass a string and an int, it won't know which one to use.
And it'll assign the value of empty space and 0 to both of them as well.
Well, in fact this one won't even compile. It won't compile because if you look here, there's already a constructor. It doesn't know that because I've got a constructor here that takes a name and an age, an owner's name and an owner age. So if you look at your program over here, this one, it doesn't know which of the two constructors you need because I got one with a string and one with an int. Yeah.
If you swap around for one of them, if you put int,
yeah,
string would work.
Definitely. It would compile then, certainly. Yeah, because it knows then that if you pass an int as the first parameter and a string as the second parameter, it knows it has to call the one that takes an int as a string. Now, that one will compile okay, right? Is that the question you were asking?
It was, actually.
Just about if you have multiple constructors that take the same parameter list, it won't know which one unless you actually specify different types. Alright, this one will compile because this one, it's clear then over here in the program when you go Daisy and 10, it has to call the one that takes the string first and the integer second, not the one that takes the int first and the string second. So that's how it disambiguates by the list of the parameters. Is that alright with everybody?
Is it therefore better to have constructors as different names?
No, you can't. Your constructor is always the same name as the class. You can't actually have a constructor with a different name. And it never returns anything. So you notice there's no void or int or anything there. The constructor doesn't return anything. It just creates the object, and that's how a constructor works. That's the rule. So, just to jump back to where we were in the program, right? Let's just come over here again. So I want to just show you, this is the one that takes the string. So if I just press F5, and now I'm going to press F10, and F10 is step over, so it won't come into that function at all. Now this time it's going to come in here, equals new animal Brian. So I'm going to press F11 to step into that. And you'll see it's used the one that just takes the string name, and then it goes this name, so whatever parameter I've passed in, it's going to get passed in, and it's going to use 0 as the age parameter. So when you press F11, you'll see it'll jump into this constructor here. Is everybody clear on that? So that's what the this means when you use it in that context. It's a way of making use of the same constructor. You know, if you want to, you have one sort of joint constructor which does all of the special constructing. You can have different ones that take different parameters that just call that constructor, and that's the way you call the constructor. There's a different syntax for this in Java and a different syntax for C++, but it means the same thing. So then we just have a look at the last one, right? We press F11 again, step in here, and this is the one that takes the string name and the age. So that's the one that gets called there. All right, so that's what this means in that context there. So now what I want to do is I want to create a subclass of animal, and I'm just going to create two subclasses here. Let me create a dog subclass and a cat subclass. All right. So there's my dog subclass. Zoom in here again. I'm going to make that public class because that's what we always like to do. Now I want to say that a dog is a type of animal. How do I do that? Colon animal. All right. So that means a dog is a subclass, or a derived class, or a specialization, depending on which books you read or which language you're working on. But the principle is that everything an animal has, a dog now also has. So a dog has a name and a dog has an age, right? So we can make a constructor for the dog as well. So we want to add animals, just add the breed field for the dog, right? String breed. I make that private. Private string breed, and now we want to make a constructor for the dog. Public dog. And let's make one that takes the breed, the name, and the age. Oh, sorry, string breed. Okay. Now again, I want to say in this one here, yeah, I already have a method for setting the name and the age, so let's just make use of that and we'll just do the extra thing. Colon, is it this I use here? No, it's not this. Okay, so this is just a little language thing. I need to verify this. It's base. No, maybe it's colon base. What is the syntax for calling the base class constructor in C#? Does anybody know that read the chapter from the book? I mean, I read it, but I forget, because I do these, forget the different languages. I want to call the 3-argument constructor. How do I do that? In Java, you do this. If you've done Java before, but in C#, it's definitely not that. That's the C++ syntax. Will base not do it? Let's just try this and see what happens. Okay, so that's not the syntax here. Colon.
And use this.
Yeah, if you use this, it just shows you the ones in the current class. It just shows you the dog and the thing. Okay, let's use Google here, huh?
If you use colon base, it does it. It shows the animal class.
Does it?
Yeah.
I thought it was colon base. Oh, great. That's how you do it. All right, excellent. Colon base, and the one we wanted to call was the one that takes the name and the age. So let's go name, comma, age. And then the breed. An animal doesn't have a breed, a dog has a breed, so you can go this dot breed equals breed. Okay, let me make the no argument one here as well. This dot breed equals the empty string. Okay, so here's the thing, right? What I want is when you construct a dog with the name, the age, and the breed, you know, because a dog is an animal, I don't just want to set the breed, I need to also set the age and the name. So I want to call the base class constructor. So this is an example in C# of what's called constructor chaining. So, you know, what I'm saying here is when I create a dog, well, a dog is also an animal, so you also have to create an animal. And the animal constructor has to be called. And the one that I want to get called is the one that takes the name and the age. So I think the best way to do this is to actually run it. We'll just, hopefully, by looking at, you know, the sequence of what gets called, then we'll be clear. So I can come over here, animal, and let's make it dog. Misty equals new dog. So you notice here that there's actually two ways of calling this, right? You can go equals new dog like that because I've got a no argument constructor. And you can also go dog, Shane, what's your doggy called?
Mr. T.
Mr. T. And we can pass in the 3 here, so you can go, the name is Mr. T. The age is 7, and the breed is
King Charles.
okay, so my dog is a King Charles too. Right. So I want to just do this here. Let's do the Mr. T one first because we've kind of spent a bit more time thinking about that. Control X. Bring this back up here again. So I'm going to press F9 at this point to get my program to stop, and let's watch the sequence of the constructors getting called here. So I'm going to press F5. Right, so you go dog, Mr. T equals new dog. I'm passing in the name, the age, and the breed. I'm going to press F11 in Visual Studio. What are we going to see here? We're hopefully going to see, when you go colon base, it will then call the base class constructor and pass in the name and the age. So I'm pressing F11. And there we go. Where are you? Yeah, there's the one taking the name and the age. So name and age. And now it's going to set the breed. So there's this dot breed equals breed. Cool. So now when you hover over Mr. T, you can see that it has hopefully set the breed. And there's the things from the base. So Mr. T is age 7, the name is Mr. T, and the breed is a King Charles. So there you go. So it's set everything. So there's a new keyword, base keyword, and the this keyword. And that's the constructor chaining thing. Watch what happens when you do dog Misty equals new dog. I want to show you this. This is kind of slightly confusing, but anyway, this is the way it works. Actually, before we even do this, let's take a quick look at the code first of all. This dot breed equals the empty string. What's the name and the age going to be? What's that?
Empty string and 0.
Yeah, so why? What does that tell you? If it's the empty string and 0 and not null, what does that tell you must be happening?
It takes the values from the main class. Dollar sign.
It takes the value from the base class. So the only way you can do that is if it calls the base class constructor. So watch this. If you don't specify call the base class constructor, implicitly C# will do it for you. Because it knows you can't create a dog. A dog is a type of animal. What are those values going to be? It doesn't, you know, they have to have some value. So it will take them from the base class constructor. So I'm going to press F11 to step into this. And there's my dog. Whoa. Base, name, and yeah. So why didn't I see that in the debugger? Let me run that again and just get it to debug. Stop debugging. So there's Misty, and I'm going to press F9 here. So I just missed that. I didn't see it jumping into that, but I know it does call the base class constructor. Dog Misty equals new dog. F11 to step into. Yeah, there we go. So implicitly, you see it has jumped into the animal base class that takes no argument. So even if you don't tell it to call the base class, it will always call the base class no argument constructor. If you don't tell it explicitly which one to call, that's the default. And then it will call animal, set the name, set the age. And then if I press F11 again, it's doing this constructor, and then it will do this constructor. So this dot breed equals the empty string. What do you think? Is that alright? Has everyone been able to follow that along and pay attention? If you haven't, then you can watch back on this video, and not only that, I suggest you type this program up yourself. And I suggest you step through it line by line using F10 and F11 in Visual Studio and write down the sequence in which you can see those constructors getting called. So there's two reasons why I think you need to do that. Number one, this is kind of one of those gotchas in in any of the OO languages, figuring out what constructors are going to get called when you have inheritance. And it's the typical question you're going to get in an exam. I'll give you a little scenario like this and explain the sequence of constructor calling and stuff like that. The other reason is, this is again a typical kind of interview question. You'd be asked this kind of question: when is the default? Why do you make a default constructor? So the reason why you make a default constructor, apart from any other reason, is because if you make a subclass of a class, and then the default constructor gets called automatically. That's why it's called a default constructor. When you're making a dog is an animal, so you have to also construct an animal as part of the dog. I don't know, that doesn't really, logically doesn't make, English-wise it doesn't make a lot of sense. But because a dog is an animal, you're also constructing an animal when you construct a dog, is the way to think about it. And you have to be clear about how the constructors are getting called. Are you confused yet? Is everyone okay with this? Take the time to step through this in your own time outside the classroom, right? It's very important, and tomorrow's lab is going to be based on this, because there's one last thing I want to show you, right? We did say last day that all animals can speak, okay? So we can make a method on the animal class. Is that video still going there, yeah?
Yeah.
Good. Public, void, speak. Now, animals can speak by going console.writeLine. And what do animals say when they speak? Animals. Huh? It does depend on the animal, really. So it doesn't make sense to say an animal speaks, does it? Only a dog can speak, or a cat can speak. Well, technically, or a human can make a sound. Animals don't really, we can't think of an animal. You have to think of what does a specific animal do, right? So we could say something like this: I can't speak. I'm an animal, okay? So this is just a very contrived example to illustrate this point, okay? Now what I really want here is I want to make a version of speak in the dog and a version of speak in any other subclasses. So how do I do that? How do I basically say I'm going to make a version of this in the derived class? There's two words that go together, do you remember them? In the base class you put virtual, and in the derived class you put the word override. And virtual and override go together. So now we can go public, override, void. Oh, sorry, it even tells you, look, you can override these ones. By the way, I didn't make a method called equals or get hash code or toString. Where did they come from? They're built in because every class that you make extends a base class called object, whether you say it or not. Alright, so every class, every instance of the class has got an equals and a get hash code and a toString. So public override speak. Where are you going there? Speak, that's the one I want to change the behavior of. Look at that, base.speak. What do you think that does? Calls the method in the base class if you want it. So by default you get that. You don't have to do that, right? But if you want to call the method in the base class, you call base.speak, and that will call the one in the base class. But we want to do console.writeLine. Okay, so we've got name says woof woof. Alright, so that's what happens when you do speak, okay? And that's hopefully just going to make sure it all compiles. Bill succeeded, okay? And now we'll make an example of calling that speak method, right? So I can now go, let's get rid of Misty, and let's use Mr. T today. So Mr. T.speak. So, dog Mr. T equals new dog, Mr. T.speak. Which one will it call? The one from animal or the one from dog? The one from dog. And you can verify that by running the program. If you're not 100% sure, press F11 to step into it, and you can see, there you go, that's the override. That's what virtual and override means. Alright, even though there's one from the base class, I'm using this one instead. Now, let's modify our program just very slightly and let's change it to this. Animal. A equals Mr. T. Okay?
What's wrong with you?
Okay, got already one called A. That's called A-N-I-M-A-L. Animal equals Mr. T. Okay, look at this here. Is this okay to do this? This is the same as doing something like this, by the way. Animal X equals new dog. So both of these kind of mean something similar. You're taking something which is a dog and assigning it to be an instance of something which is the parent class or the base class. So are these okay?
Why not?
Definitely. They are 100% okay. This is an example of polymorphism. This is the other thing in OO, and I'll do another example of this, and you can do it in the lab tomorrow to get some practice on it yourself. This is an example of something which is an animal being assigned something which is a dog. And that's okay because a dog is an animal, isn't it? If we had a cat class, you know, you could do the polymorphism thing when you could change animal from being a dog to a cat. Okay, which we did last week. But anyway, the question now is if I go animal equals Mr. T, and then I go animal dot speak. Which one does it call? The dog one or the animal one? The dog one or the animal one? The dog one. Okay, this is really, really fundamental to everything to do with OO. So you need to be 100% clear in your mind that it is the dog one that gets called here, not the animal one. The type is animal, but the instance is dog. That's what virtual and override mean. That's what they mean. You're asked for a definition and an example of when you use virtual and override. It's exactly this situation here. When you basically use the base class type to instantiate a derived class. That's when you use virtual and override, and they go together. And in this example here, it's going to call the dog one. Even though the type is an animal, the instance is a dog. This is what OO is all about. Okay, let me set my breakpoint here. Again, this is how you prove this to yourself, and this is how you learn. Okay, animal.speak, hitting F11 to run the debugger. Press F11, and there you go. That's public override void speak in the dog class. Is that okay with everybody? One last thing, which is related to this. And this is something I really don't want you to ever do, because this is a very confusing thing in the C# language. It doesn't exist in Java. In Java, that's always what happens. It will always call the one from the derived class, even if you instantiate it as being the base class type, right? But watch this. What would happen if I forget to put the word virtual in here, and over here in dog, I forget to put the word override, and I build it again, and I got 0 errors, so it compiled, okay? Have a guess at which one it will call now. Huh? It will call the one from animal. So the reason why is because there are two ways of finding the right method in C#. One is called a static bind of the method, and the other is called dynamic bind. It's nothing to do with the static keyword. If you don't use virtual and override, it uses static binding. So in other words, it will always use the type to look up the method. If you use virtual and override, it always looks up the instance to use the method. So just to prove that, I'm going to press F5. I'm going to press F11 to step into this, and look at this. I can't speak, I'm an animal. So virtual and override go together, and if you expect to be overriding, you know, you should put virtual and override in. It's just a confusing thing about C#, right? C++ has exactly the same thing, static and dynamic binding. Can anyone think of any good reason why you might use static binding? There's only one reason. As opposed to doing this virtual and override all the time. Virtual and override, it makes a lot more sense. Is there any reason why you might not want to use virtual and override? Can anyone think of any reasons? You mightn't even realise this. Well, I'll tell you, it's something that you mightn't even realise. This is slightly less efficient in terms of the CPU, okay? It's slightly more efficient to use a static bind, but static binds, that's the only reason. So they include it in the language, so you can choose whether you want to use static or dynamic binding. In Java, it's always dynamic binding. In C++ and in C# you choose static or dynamic binding. But I recommend you always use dynamic binding by using virtual and override. Those two things just go together, and always use them if you intend to change the behavior of something. Okay, that's it. Does anybody want to ask any questions? Okay, so I think we better do a little exercise before we finish up. What time is it? 10. Okay, so you got 10 minutes then, right? I'm going to write up a whole load of new keywords, and I want you to write a definition for each one. And you can work together, you know, to put all these definitions together. Just let me give you a page, I'll just clean the board. Thank you. So between now and the end of the week, I need everybody to write their own definition and their own examples for each of the following, okay? Number 1, what does that mean? The colon, like that. Number 2, inheritance. Number 3, the word this. What does it mean in C#? Number 4, a constructor. Anyone got a whiteboard marker? Sure, now I'll type them up, right? That's probably the best thing, because you won't be able to read them off the board. And you can start this now, okay? And tomorrow I'll go through each of these definitions. In fact, it's probably better I type them up. Okay, number 1 is the colon thing. What does that mean? Number 2 is the word inheritance. Number 3 is, what does this mean? Come on, computer. Number 4 is a definition for a constructor. Number 5 is the word class. Public, private, protected. Accessors, which is basically the get and the set thing. The word class, I think we put that in there already. Instance of a class. A reference. Oh yeah, the word base. Oh yeah, virtual. The word static. And then this other thing which I talk about is method binding. What else did we do? Base is there, yeah. Constructors, inheritance, yeah, polymorphism. Polymorphism. What else did we do in this section? Yeah, constructor chaining. Static and dynamic binding, constructor changing, accessors getting set, base, colon, inheritance. Anything else? I think that's it. Okay. By the end of the week, will you make sure that you understand each one of these terms? Make sure you can do an example of each one of these. If this is a keyword, you need to go and, look it up in Rob Moyle's yellow book or do a Google search for an example and take responsibility for understanding each one of these things. And on Friday, we'll make our first game. Did I tell you what it was called? Misty bats. Alright? That's it.